Hello, 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 everybody, and welcome back. We're on question number 16 now of the 2008 Grade 8 Gauss paper. And question 16 says, a 4x4 square grid can be entirely covered by 3 non-overlapping pieces made from 1x1 squares. If the first 2 pieces are this sort of almost gun-looking shape, and sort of a sideways C or maybe a horseshoe shape, the third piece is, and then we're given 5 possibilities. Okay, now, with a question like this, it's not exactly approachable by strict sort of, you do this, 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 and you're done. And some of us like those parts of math where you can say you do this, 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 and you're done. A lot of algebra questions are, okay, name your variable, set up the equation, rearrange, solve for one variable, plug it into the other thing, and there's a nice little process. Okay, these are things that lead to algorithms, things like Gauss-Jordan elimination. Sorry, Gauss-Jordan elimination, not Gauss-Jordan. But Gauss-Jordan elimination is a very strict process to get from a system of equations to a solution or solutions. And there's lots of those in math. But this one here, there's not here are your 2 shapes. You gotta have this, and you gotta have this, and therefore, add up all these, and it's gonna have to look like D or whatever. This one is absolutely something you have to play around with. Now, the shapes here are not so bad. I think this was even on the grade 7 paper as well. What we're going to do is we're just going to draw a 4x4 grid and say, well, what if the one piece was here, and the other piece was... Oh, no, they overlap. Okay, what if the one piece was over here, and then this one fits in here, and what's left over? That sort of a thing. And that's all we're going to do. Okay? So we'll draw our 4x4 grid here. Okay, now, what are our pieces? Well, we've got one that's 4 across and then 2 below it. And the other one, as I mentioned, sort of looks like a horseshoe. Okay, so there we go. So we just have to play around. If we can get these 2 to fit on the grid, and, maybe just draw a really quick grid. Maybe, we fit them in on the grid and it turns out all of this part here is filled in. We'll know that what's left is, okay, it's going to be a 2x2. That's the piece that we could pick. However, there might be some way to fill in the grid with these 2 pieces, and what's left over isn't a third piece. If I had something like somehow they cover up all of this. And then, okay, what's left? Well, there's this 1 square down here, these 2, and these 2. The instructions quite clearly say 3 non-overlapping pieces. So in order for us to have a unique answer, there must be only one way to put these 2 pieces on the board and get one connecting piece. And that's what we're looking for. That's what we need. And you just sort of play around with it. My attention is drawn to this big piece here because he's got 4 across. So whether I lay him like this or like this, I'm missing one, there we go. He's going to cover a whole column or row, and that's pretty interesting. So for example, if we used maybe purple just to indicate where he is, if I placed him like this, he sort of chops the board almost, not in half, but into 2 pieces. And that's pretty interesting. It's also kind of dangerous because we don't want this second scenario where pieces of the board aren't connected. Okay, and then, the question is also, wherever I place this guy, where can the horseshoe fit in? You'll see if I place the first piece, the sort of gun-shaped piece, this way, I can't fit in the horseshoe. So we got to play around with it a little bit. And you can try lots of things. I'm not saying there's one right way to lay the pieces. I'm saying it's a 4x4 grid, so there's going to be a lot of rotational symmetry. But the idea that this piece here will cut things in half is pretty powerful. And you sort of realize, well, no matter how it cuts it in half, I'm probably not going to be able to fit my horseshoe shape in the remaining slot, in either of the remaining slots. And even if I do, it's got to take up the whole slot. So you're led pretty quickly to start to realize, well, maybe I can just put the gun shape up against the side. See, there I haven't split this into two pieces. And you start to hit upon that idea. Okay, he's sort of tucked away in a corner now. Let's talk about the horseshoe piece. And there's lots of places it can go. You know, it could be flipped up like this. And hey, these aren't overlapping, but we've got pieces left over, sort of an L piece and then a lone square. So that's not quite going to work. That would need to be three. Or sorry, we need to have three, and that would be four pieces. Okay, and you can try other things, you know. Something like this, but okay, that's going to have the same problem. It's not connected. Or, you know, you could move it over. But that's even less connected. Now we've got three other pieces left over. And you mess around with this one a little bit too, and you hit upon the idea that, okay, what if I tried something like this? And then, what have we got? We'll highlight it in blue, but we have sort of this blue, these blue X's together, they form what that's called the blue piece. It's left over, and it's a single piece. It sort of looks like a mini gun, or a Tommy gun, or something like that. He's a shorter version of this piece. And so, okay, these three pieces, they're not overlapping. There are three pieces. This should be it. Is this one of our possible answers? And we go and we check, and yep, sure enough, C. So, just bubbling C. There's not a big trick to this question. It's very much a spatial reasoning, and can you play around with it? Can you do guess and check? And those are still important questions to be able to do when they come along. Okay, it's important very much in math, not just math contests, but in math, to be able to play around with something, to try things out, and to not get discouraged if they're not working out, and to go back and try again. Okay, I see this problem a lot of times with my students. You know, especially if they're learning things like linear algebra, which can be very algorithmic, can be very, you know, you do this, you do this, you do this, you do this, and you're done every time. And, you know, they're great at that because you can switch your brain off. You just sort of follow the instructions. But what I never ever see is a classroom full of students who are all able to just say, oh, let's try this out. Let's just, you know, develop our own way of doing things. Let's think through the problem. Let's try crazy ideas and see if they pan out. People get discouraged quite quickly. And so it's an important skill that you can develop in these math contests to be able to just say, okay, here are the things I need. Here are the things I have. Let's just go nuts and try and get from point A to point B. Playing around with things is a great way to learn how to do that. Okay? So, that's it for question 16. I will see you guys in the next video for question number 17. Until then, take care.